Hi everybody, it's Mrs. Dinkelman, and these are the notes for lesson 4.4, where we're going to talk about technically two things, although they're very related. So whether a function is increasing or decreasing, we're going to try to do that without looking at a calculator or a graph. And then this first derivative test for relative extrema, so finding relative or local mins and maxes. So he has some procedures there. Here's the basic thing that we need to know. We're going to find the critical numbers where the derivative is 0 or undefined. And then we're going to do a number line analysis with those critical numbers. And we're going to be deciding whether the derivative is positive or negative. If the derivative or slope is positive, we know our function is increasing. If the derivative, which again means slope, is negative, we'd have a function that is decreasing. And then we know that our relative mins and maxes are potentially at where the derivative is 0 or undefined. So we will also be able to decide where the mins and maxes are. Okay, I'm going to kind of skip through this a little bit. We're going to talk about what all that is in just a second. I guess maybe I can highlight a little bit. This x cubed right here, that is always increasing. So think about the function here. Even though there is a little blip there, and we would find that the derivative is 0 right there. So there's just a little bit of, I don't know if it's confusion, but maybe some mathematicians prefer to say that it's not increasing at that particular locations, but some textbooks like to say that it's always increasing. So they're not going to really trick you on that particular one, but we'll kind of talk about interval notation as we're going through here. Okay, so you might actually be able to just see one example here and kind of know what's happening. I'm sort of wondering if, I think we're okay. I'm going to go ahead and just do number one, but I'm going to take a lot of space here. So we're going to find the critical numbers here. So remember that the critical numbers are where the derivative is 0 or undefined. So I'm finding the derivative here. This is a chain rule thing. Again, we want to know where this is 0 or undefined, so it is worth our time to simplify a little bit. 3, let's see, cube root. I think that looks good. So sometimes with these rational ones, I like to just figure out where the top is equal to 0 and the bottom, because that, if the bottom is 0, it really means we have an undefined function. So here we're going to have an x equals 0, and then here a plus or minus 3 is a problem. So we're going to include all of those on our number line, all the critical numbers. So with this number line, I guess I'll put it over here on this side. What I would recommend is that you label it as f prime, so that when you're doing a free response and somebody else is grading it, you are doing as much as possible to communicate what you're doing. And what we're analyzing here is the derivative. And then we have our critical numbers or critical values that we want to put on that number line. So now we want to just determine whether the intervals here are positive or negative. You did this a lot in pre-calc at the beginning when you were doing inequalities. So that's what we're going to be doing here. So you're going to pick a number. I generally don't write down what number I pick. You could do that like maybe on a rough draft, and then when you kind of bring your thinking all together on one page, you would probably not want to have those written in. So let's see what happens if I pick a -4, for instance. So if I plug a -4 here, the top would be negative, and let's see about the bottom. The bottom would be a positive because -4 squared would be a positive. So I think we get a negative result in that interval. Let's try -1. So again, the top would be negative, and then the bottom here, if I plug in a -1, I'm going to get a negative. So the result of that one is going to be a negative. Okay, let's try a +1 maybe. So that would be a positive over a negative. I feel like I did. I'm going to go back and look because I feel like I maybe made a mistake, but I'm going to keep talking and we'll go back. And then let's pick a +4. So that's going to be a positive over a positive, which would be a positive. So let me double check those all because, again, my brain is thinking I maybe said things wrong. So if I plug in a -4, I would have a negative over a positive, which is a negative. Okay. Negative over a positive. When I pick -1, for instance, I'm going to have a negative over a negative, which is a positive. Whew, I'm glad I checked. And a +1, positive over negative. Okay, looks good. Normally those alternate, which is partially why I was like, oh, that looks weird. Remember, if we have a double root, it probably won't alternate over there. Okay, so let's go back and look at the question again. It wants to know increasing and decreasing in all local points, local extrema points. So let's just kind of write out our answer here. So for increasing, we're going to look for all the spots where this derivative is positive. And so we have -3 to 0. So most books will teach you that those should be hard brackets as long as both of them exist on the original function. And I think that is the correct answer. My brain doesn't like it. I would rather say parentheses, because I know at -3 the derivative is undefined, or at 0 the derivative is 0. But you can decide what you want to do there. They will not mark you off for having the wrong bracket versus parenthesis thing there. So I like to do parentheses, just so you know, but I think brackets are probably most appropriate. So probably a bracket here would be the best. Decreasing. So negatives, again, same conversation. We're just picking the negatives now. Again, probably it's supposed to be brackets. Again, if you put parentheses, you're going to be totally fine there. Okay, it also wants the local points of extrema. So let's kind of think about what the shape of this thing is. So we have negative, which means we have a function that's decreasing, and then it increases, and then it decreases, and then it increases. Okay, so now we know that there are some spots where we have local maxes and mins. So let's go ahead and say we have, and do we have to find the points? Yes, we do have to find the points. So local min, let's do that one first, is going to be at -3 comma something, and then 3 comma something, and then our local max is going to be at 0 comma something. Okay, so I'm going to find the 0 first, maybe. So -9 to the 2/3. I don't really like that. We'll just call it -9 to the 2/3. They'd be happy with that. We can use our calculator to find that. And then if I plug in 3 and -3, luckily those are zeros, so I like that. That one turned out kind of nice. Okay, so if you want to, you think you got it at this point, again, the strategy is find the derivative, find the critical numbers, do a number line analysis, and then you can find your answer from there. That's the basic steps for finding increasing and decreasing, and then also our local min and local maxes. So I'm actually going to pause there and let you go for it. I don't like the video to get super long, so go ahead and get started, but certainly let me know if you're running into any issues with those assignments, questions, okay? Good luck.